Hello students, today we will be going over 8.1, investigating solutions to linear inequalities. Our objective, I can graph linear inequalities with appropriate boundary line and shading. So a linear inequality uses inequality symbols. Linear inequalities divide the coordinate plane in two. That's divide coordinate plane in two by a boundary line. Just put by a boundary line. Where one side represents solutions. Where one side represents solutions. So a couple of examples you could put over to right over here would be like, okay, there's your graph. Here's a boundary line. See, that's a straight line shaded down there. Means all of these are solutions on this side. It could also be something like this, where it goes down and to the right, and maybe shaded on this side. Okay. All right. And a solution to a linear inequality, graphically, it's all the points x, y, where the inequality is, and you want to put true in that spot. Algebraically, all the points x, y that make the inequality true. Okay, so here's our example. Determine which ordered pairs are solutions to the linear inequality. 2x minus 3y is less than 15. Okay, so we want to see if 2, 5 is a solution. So if I put 2 in for x, that's going to be 4 minus 5 times 3 is 15. Is that less than 15? 4 minus 15 is negative 11, and negative 11 is yet less than 15, so that's true. Can you guys see that okay there? I don't think that you can, so let me just move things around a little bit there. Okay, so yes, this is a solution. 2, 5 is a solution. Then I go to negative 1, negative 7. If I put negative 7 in for x, that's negative 14 minus 3 times negative 7 would be a plus 21. Is that less than 15? Okay, so 2 times, 2 times negative 1, that's the x. 2 times negative 1 is negative 2, plus 21, is that less than 15? Okay, that's 19. Is 19 less than 15? No. So that's not a solution. Okay, so let's go on to the next one. 3, negative 4. 3 in for x will be 6 plus negative 4 times negative 3 is 12. Is that less than 15? 6 plus 12 is 18. That is not less than 15, so that is not a solution either right there. Okay, 0, 0 is going to be easy. 0 times 2 is 0 minus 0. Is 0 less than 15? Yes. So that makes a true statement. So there's your solution. And the first one here is also your solution. None of these others are a solution. Now we're going to go on, continue and do the middle to the bottom part. Determine if each of the ordered pairs are solutions to the linear inequality. I'm going to move this back up. Hopefully you can still see that okay. Need the hall light on because it looks dim. 0, 0. So we're going to put 0, 0 in there and see if it makes a true statement. Is 0 less than negative 2/3 times 0, 0 plus 1? Is 0 less than 1? Yes. If it is, this is a solution. Let's try 6, 1. Is 1, because this is our y, less than, okay, negative 2/3 times 6 plus 1. Negative 2/3 times 6, I think that's negative 4, plus 1 is negative 3. Is 1 less than negative 3? No, so this is not a solution. Okay, 3, negative 1. Let's see if that's a solution. 3, we're going to put negative 1 in for our y. Is that less than negative 2/3 times 3, which is that less than negative 2 plus 1? Is negative 1 less than negative 1? No. So that's not a solution. Next, we're going to go on to the last one, negative 4, negative 6. Is negative 6, because again, you want to put your y value less than, that would be positive 8/3 plus 1. Okay, this is all positive, this is negative. So that is a true statement, yes. So we know that this is a solution. So our two solutions here will be the first one and the last one. Okay, I'm going to go ahead and have you do number 2. I don't know if we want to pause the video or you can come back and do that one. Okay, x and y are very similar. I will do one of them, but not both. Is y greater than or equal to negative 2? Here's my y. Is 0 greater than or equal to negative 2? And the answer is yes. So this is a solution right there. I can put a happy face there because we're happy. 5. Is 5 greater than or equal to negative 2? No. So this one's not a solution. So again, I'm only looking at the y value here because it just says y, and they don't even consider the x. 3, negative 4. Is negative 4 greater than or equal to negative 2? No, so that's not a solution. 4, negative 2. Is negative 2 greater than or equal to negative 2? Yes. So this one is a solution. So the first one and the last one are solutions. Okay, I'm going to let you do 4. And I'm going to go ahead and go on to page 143 and show you how to do that. I might have to go ahead and move it closer because I know this is hard for you to see. Okay, select the points that are in the solution of the inequality. Select all that apply. And I'm going to do this from the graph because I think that's the easiest, and then I can double check it with the algebraically here. 1, negative 3. So 1, negative 3, that's right there. If it's in the shaded area, it is a solution. So that one's a solution. 1, negative 1, 1, negative 1, that's on the dotted line. So if it's dotted, it's not included. It's just a boundary. So it's not a solution. Negative 3, negative 5. Negative 3, negative 5. Yes, because it's in the shaded area. Negative 2, negative 2. Shaded area, you're good. 3, negative 3 is 1, 2. Right there. White area, not a solution. 0, 3. Right here. White area, that's not a solution either. So you have your 3 solutions right there. Now you can go ahead and go on to number 6. I will go ahead and do either 7 or 8. I don't know what's harder. I can go ahead and do this. Substitute the given points into the equation to determine where to shade. So here we have two boundaries. We don't know if we should shade the top or the bottom. So we're going to find out, is C in the solution? C is -3, 1, 2, 3. So -3, 3. We're going to find out if that's a solution. So I put the y value 3. Is that greater than or equal to, and it's 5/3 times x. X is -3. So 5/3 times -3, I think that's going to be -5. Is 3 greater than or equal to -5? No. So I'm going to put no. Now D should, since that didn't work over here. So D is at 3, -3. So again, we're going to put y is -3. So that goes on that side. Is that greater than or equal to, our y value is -3. So I put -3 times 5/3. And, oh, it's times our x, so that's +3. 3 times 5/3. And I think I did this backwards. So 3 right here was the y. So 3 greater than or equal to, and if I take -3 and multiply that, I get -5. Yes, 3 is greater than or equal to -5. So yes, that's a solution. So yes, that's true. This one down here is -3 greater than or equal to 5. No. So that one's no. So the one that is 1, we can shade over here. Now it says to choose 3 that are in the solution. So any of the points here. So I could go 0, 1, because that's right there. And again, it's shaded. I could go 0, 2, because that's right there. And I could actually go -1, 1. So if I put any of those in algebraically here, it should make the equation true. Okay, go ahead and do the ones I didn't do, 6 and 7, and you can do the rest, students. You rock.